Hi, this is Ed Turkel, the Manager of Portfolio Marketing for HP's Hyperscale Business Unit, and welcome you here to SC12 in beautiful Salt Lake City. Hybrid computing definitely seems to be the talk of the show here, with the launch the other night of Intel Xeon Phi and a lot of activity with our friends at NVIDIA and the new Kepler GPUs. And we're partnering with both of those companies to deliver a complete line of purpose-built servers for high-performance computing designed to be used with coprocessors and accelerators. So even seeing behind me some of our SL6500 servers in the rack behind me, where we've been able to incorporate, we've integrated Intel Xeon Phi and NVIDIA Kepler accelerators into our SL6500 family, the SL250S Gen 8 server, which is a 2U server that will take up to 3 accelerators, and announcing here at the show the SL270S Gen 8 server, which can take an amazing 8 accelerators in a integrated 4U server that you put 2 side by side, giving as many as 16 accelerators in a 4U enclosure, giving tremendous performance density, accelerator density, if you will, while also being very affordable, of course, and very power efficient. So we're seeing this as very much the trend going forward as our customers are looking at the applications they're running, which runs run best on the different types of accelerators. HPC customers have unique requirements. We're always being asked how, as a general purpose server company, can we provide for the unique needs of a high performance computing customer? The answer is very simple. Our server business is in fact structured around different workloads. So we have the traditional rack-based systems, our ProLiant DL servers, and those tend to be focused on very general purpose use, but also in areas such as small and medium businesses, OEM activities, and so on. So there's a focus there. Our HP Blade system, the BL servers, is very much of an enterprise server, very popular in enterprise customers, industrial accounts, and so on. Very popular in business computing environments. But then the hyperscale business was actually created to focus on those markets that require purpose-built servers for large scale-out environments. So on one side, we do that for service providers, some of the largest web properties in the world that people are familiar with are our customers, as well as for HPC. And in fact, there's a surprising amount of commonality between those two parts of the market. So we're able to develop an entire product line, the HP SL series, ProLiant SL series, that is dedicated specifically to the hyperscale market, with some servers that are specific to the service provider market, and the SL6500 that I noted before that's been designed specifically for HPC. Again, incorporating the latest generation accelerators, incorporating highest performance memories, highest performance processors, highest performance FDR InfiniBand, all in a very integrated solution that is becoming very popular in the high performance computing market. And we've seen with the new top 500 list, a few new sites coming out based on these new systems. One of the major factors that we're seeing is becoming a true impediment, if you will, to the growth of HPC in many of our customers is power and cooling. They're simply reaching the limits of what they can cool in their data centers. They're reaching the limits of what they can afford to spend on power, or depending upon what region of the world that they're in, they simply may not have the ability to deliver very much power, again, depending upon the facilities in their region. So we've become extremely focused on how we can deliver HPC technology in the most efficient, most easily cooled packaging. So the SL family has been designed very much that way, but we're introducing entirely new product lines focused specifically at energy efficiency. So a year ago now, we started talking about a new project that HP is doing called Project Moonshot. This is a new approach to building servers based on low energy server technology, the kinds of servers that you'll find in your smartphone or in your tablet. Basically single chip computers that use very, very little power, that we can aggregate with a large number of them into a server infrastructure with the federated networking and management and power and cooling to deliver a substantial amount of computing power for appropriate workloads, but using very, very, very little power. So in the rack behind me, we have our Redstone development system, which we started talking about a year ago. That system is based on the Calxeda ARM processor. This is an ARM technology, single chip computer. We put 288 servers based on that technology in 4U of rack space. If we filled that rack behind me with them, there'd be almost 2,000 servers in that rack. All running very, very low energy, not targeting the most aggressive HPC workloads, but at the same time, a number of HPC workloads will work just fine on that. We're going to be shortly, in early 2013, introducing the Gemini production platform, which will be based on the Intel Atom processor, which again takes that the next step. That's, as said, a production platform that'll be commercially available. And that'll be based again on a federated architecture into which we plug server cartridges. Each of the server cartridges are based on a low energy server, and there'll be different variations of that based on Atom, based on ARM, coming in the future, targeting different workloads from very simple lightweight workloads to more extreme ones that we're able to do by mixing and match the right processor for the right workload, but again, designing it very, very specifically for low energy. Just a few months ago, in September, we talked about a system that we're going to be delivering next year to the National Renewable Energy Labs, or NREL, which is a next generation of moonshot technology where we're adding in warm water-based cooling into a whole rack infrastructure that will allow us to deliver the highest levels of HPC performance in an extremely efficient package that is completely designed for what NREL will deliver as what they're expecting to be one of the world's most power efficient data centers. So we're real excited about that, and next year when we're at supercomputing again, we'll be thrilled to show you some more about what that technology is looking at.